Today I am Nancy Nan and my class is BSc third year and my roll number is 227053 from SFS. Today's my presentation of topic is covariant vector, contravariant vector and max tensor. Firstly, I am going to explain about covariant vector. So first of all, let Mn be the vector space of covariant vector of a function mu defined as the given and satisfied following property, and the property is also given the collection of such type of a vector defined above are denoted by the star and from vector space with respect to two operations that defined as mu plus delta into lambda equal to mu lambda plus delta lambda, and the second operation is also given as is known as covariant vector space or space of a covariant vector, and vector of this space is known as covariant vector. So now we will know about law of transformation of covariant vector. So let start with the space of covariant vector and ei dash. These are the two bases of star. Let mu belongs to star and mu I dash are component of mu with respect to basis. That basis is given ei and ei dash respectively. Then we can write in this way, and we know that by change of basis, the when we change the basis we get this. And now it is the law of transformation of covariant vector. We can write in this way, in this form, that written copy, and the next one is it is also the law of transformation of covariant vector, and the sum of important points are also given about covariant vector. The first of all is if ai is basis for star and each is basis of covariant tensor. So when we tell about covariant, so we write, so we denote by the star, and when we tell us about contravariant, so we can write also. And in covariant we can we write in a we, we write in so we write in this way, and the covariant vector we write in this way. The second one is, now we will learn about contravariant. If ai where I is 1 to 3 are component of vector belong to with respect to basis ei and ai are corresponding component of same vector with respect to basis ei dash are related by a law, and the law is given, and this is known as the law of transformation of contravariant vector, and ai is component of contravariant vector. So contravariant vector of order 2. So when we talk about order 2, let aij are component of 2 vector uh, belongs to into with respect to basis ai and ai dash j dash are component same vector with respect to basis ai dash related by law, and the law is also given as, and it is law of transformation of contravariant tensor of order 2, and aij are component of contravariant tensor of order 2. And now contravariant tensor of order r or tensor of a type r comma 0. So when we talk about tensor r or for order r, we know that let ai1 ai2 and so on are component of vector belongs to की power r with respect to basis ai and ai, and where ai1 ai2 is so on are and vector covariant tensor of order 1 or tensor of a type 0, 1. Let ai are component of vector belongs to star with respect to basis ai and ai dash are corresponding component of same vector with respect to basis ai dash are related by the relation, and the relation is given as, it is known as the law of transformation of covariant vector, and ai are component of covariant vector, where covariant tensor of order 2 or tensor of a type 0, 2. Let Aij R component of vector belongs to mm star into mm star with respect to basis ai, and ai dash j dash are component of same vector with respect to basis ai dash related by the relation, and the relation is given as, and this relation is known as the law of transformation of tensor of type 0, 2. And now we will learn about mixed tensor or mixed tensor of a type 1, 1. Let aij are component of a vector belonging to mm into mm star with respect to basis ai, and ai dash ji dash are corresponding component of same vector where so firstly we know that ai dash and ji dash. So ai dash is covariant vector and ji dash is contravariant vector. So the of same vector with respect to ai dash related by a relation, and the relation is also given as a law of transformation of tensor of a type 1, 1. So mixed tensor of a type r, s. Here ai dash, here where it is written are component of a vector belonging to m in mmr into mms star with respect to basis, and the bases are given as are component of same vector with respect to basis ai dash related by a relation, and the relation is also given in the copy. So it is of transformation of a tensor of type r, s. So addition and subtraction of two tensor. So two tensor of same type or same order or same structure r can be added and subtracted, and resulting tensor is of same order. So thank you, thank you everyone for